All right, hello everybody. So I wanted to make sure to do an example of finding the area of parallelogram and the area of a triangle given three-dimensional coordinates. The whole idea is that the area of a parallelogram happens to be the same as the magnitude of the cross product. And so for problem number 2 here, what I'm going to do is just take 2, 3, -6, because that's written in IJK form, and cross that with 3, -1, and -4. And when you do the cross product of them, remember you have the formula from the book, or I also showed you the way to do it with a determinant of a matrix. And so I'll do the matrix way here because that's the way I can remember it. So I, J, K, 2, 3, -6, 3, -1, -4. We end up with I times 3 times -4 minus -6 times -1 minus J times 2 times -4 minus -6 times 3 plus K times 2 times -1 minus 3 times 3, like that. And then let's just do a little bit of simplifying. So I guess we get -18i, what would that be? 10, -10j. I don't know why I switched from capital to lowercase. Doesn't really matter. Minus 11k. And so that vector then is perpendicular, it's normal to the other two vectors that form the parallelogram. And some of you asked, like, how do you get a parallelogram out of two vectors? Well, remember that vectors can be translated tip to tail. And so if you have one vector like this and another vector like this in three-dimensional space, you can just grab the first vector and grab the second vector, and you create a parallelogram. And the kind of connection here is that the cross product finds something that's perpendicular to it. And it turns out that the magnitude of the cross product is the same as the area of the parallelogram. And so what I need to do next is, this is my normal vector, so I'll just write it as n. And so then the magnitude of n is just like the Pythagorean theorem. You just do the square root of each component squared. So -18 squared plus -10 squared plus -11 squared. And so that just pops out to be, what is it? So 18 squared plus 100 plus 121, 545. So the square root of 545. They didn't give us any units, so I guess this is just in square units. Now, looking at problem 3, it asks us to find the area of a triangle. And just remember that if you have two vectors that form a parallelogram, well, you could just cut that parallelogram in half, and then you have your triangle right there. And so I'm imagining this is A and B and C. And so what I'll do first is find vector AB and then find vector AC, and then do the cross product of those, and then basically do the same thing that I just did on problem 2. So problem 1 is done. Let's clear the screen here. Problem 2 will be done in purple. So vector A, B, let's see, the x coordinate goes down by 3, the y coordinate goes down by 4, the z coordinate goes up by 1. I hope I didn't mess that up. You could do either vector AC or vector BC or vector CA or vector CB. As long as you just get point C involved, you should get the same answer. And that's a good way to double check your work, is to go back and try and create a different set of two vectors that span the triangle, and then you'll do the cross product. And so I guess AC looks like it goes down 2 for X, goes down 2 for Y, goes up 2 for Z. Did I do that right? I think I did that right. So then AB cross AC is the matrix I, J, K, -3, -4, 1, -2, -2, 2. And the determinant of that matrix is going to be I times -8 plus 2 minus j times -6 plus 2 plus k times +6 minus 8. +6 minus 8. All right, let's move the face out of the way. And then what do we get? So I guess that becomes -6i, +4j, -2k. That is the normal vector. So the magnitude of the normal vector, and it's a triangle, almost forgot. So 1/2 the magnitude of the normal vector is 1/2 times the square root of 36, because that's 6 squared, plus 16 plus 4, which gives us 56. Doesn't really come out to be something super nice. So 1/2 times the square root of 56. Now that is the correct answer. That's the exact answer. I'll just take this moment to remind you that you can reduce that because the perfect square 4 is a factor of 56. 4 goes in there 14 times. And so I could write square root of 56 as square root of 4 times 14, which means it's 2 root 14, which doesn't have any perfect squares in it. And so I guess that means that the area of triangle ABC, the area of it, I'll just use magnitude, which is slightly abusive notation, is square root of 14. So there you go. Let me know what else I can do to help.